All right, Algebra 1 skills number 2, rational versus irrational. So let's look at what that means, rational numbers and irrational numbers. A rational number is any number that can be expressed as a ratio of two integers. That means if you take two numbers off of a typical number line, which are integers, numbers like 1, 2, 3, 0, -1, -2, -3, and so forth, any ratio would be a rational number, except those ratios where you're dividing by 0. That's the exception, but here's some examples. Just plain old numbers. That's 6/1. That's a rational number. -1/2. 4.6, which is actually 23 divided by 5, which that's not important that you know that, but when you divide, sometimes you get decimals. 7.3 repeating, that where the 3 just repeats over and over. That's rational. And I put this one because square roots are very typical among irrational numbers, but you have to be careful with square roots. Sometimes we have a rational number in disguise because you can evaluate the square root of 4. Square root of 4 is the same thing as 2. So this 2 certainly is a rational number, so be aware of that. Now speaking of our decimals, the decimals for rational numbers will either terminate, which means just abruptly stop, or they'll fall into a repeating pattern. Okay, one of the two. They won't just ramble on forever. In contrast, we have irrational numbers. Irrational numbers are numbers that cannot be expressed as a ratio of two integers. Okay, so some examples of that. You can have 4 here. Again, square roots are very common. That's probably the most common irrational numbers are square roots of things that will not evaluate, that do not become whole numbers when you evaluate them. You also have a decimal that we talked about earlier. It does not terminate. That ... implies it would just keep going in a random fashion. So I don't intend that to be 1, 2, 3, 4, 5 or anything. It's just random numbers. And then pi. Pi you learn or will learn in geometry is important. Constants, the ratio divided by the circumference divided by the diameter. That's a famous irrational number. The decimals, again, neither terminate nor repeat. There's no pattern to that, no repeating pattern. It's just the numbers will continue forever. Okay. So one thing is to know the difference between rational and irrational. Another thing is when you combine them, what happens? Okay. So first we'll talk about if you combine. We're going to say add, subtract, and multiply, and for the most part divide too. If you combine two rational numbers in some fashion, I have to stay away from the word combine because that means add or subtract, or multiply is included there. If you put together two rational numbers, then you're closed under rational numbers. That means that the result of putting two rational numbers together will be another rational number. You can't get an irrational by operating with two rationals. A rational and then a rational makes another rational. In contrast, if you throw an irrational in the mix, it makes the answer irrational. Okay, so a rational and an irrational is going to make an irrational. The only exception is if the rational happens to be 0 and you're multiplying. We know 0 times anything is 0. That's the only exception. Otherwise, if you are working with two numbers, one's a rational and one's an irrational, and you add, subtract, or multiply, you're going to get an irrational. That irrational kind of pollutes it, so to speak. It keeps you from getting a rational back. Now, if you combine two irrationals, it's inconclusive. It's usually irrational, but there are examples to where we can rig it to be rational. For that reason, we want to stay away from combining two irrationals. There's just lots of little exceptions there that can be deceiving, so be careful with those. Let's see some examples. All right, so we're at the question here is not printed, but let me just tell you, what kind of number will it be? Will it be rational or irrational? Okay, well, here we know the answer is 7.5, but this is rational, this is rational, so therefore the answer is rational. Okay, it's that simple. Rational with rational. If you're working with two rationals, you can't get an irrational. Right here, we know a terminating decimal is rational, but the square root of a non-perfect square is irrational. So rational and irrational makes irrational. Okay, except for that one exception of multiplying by 0. Some more examples. This is a repeating decimal, so it is rational. Here we're multiplying times a square root. Again, a non-perfect square. So this is rational and irrational, which makes irrational. Fourth example, this is a decimal which looks like it terminates. And this is the square root, this time of a perfect square. So this is two rationals. Doesn't matter the operation, I'm going to end up rational. Okay, so again, two rationals make a rational. But if you mix an irrational in there, the answer's usually irrational. A couple more examples. Pi is a famous irrational number, but you're multiplying by 0. This is the exception. Okay, this is rational. It's usually irrational when you mix them, but this is rational because you multiply by 0. That's the exception, remember. And then finally, be careful here. These are two irrationals, which is usually inconclusive. Now you could work with it and think about it. This does happen to be irrational, and they usually are. But again, be careful because we can rig this, not this particular problem, but it can be rigged such that two irrationals combine in some way to make a rational. So be careful there.